Hello Internet, welcome back to our shield shader. In this video we are going to be making this actually refract. We have a refraction shader, it's already doing refraction, but it's not really refracting anything of importance. What I want to do is see all these blue things that spread out from the impact. I want to use that as the refraction. So the idea here is when something hits, it pushes the force field out or dissipates it, and so you should be able to see a wave go across, and that should actually be visual. So not just a color, but an actual wave, so it should actually make the air move. And so to do that, we can just modify the normals of what this is doing and actually just shift. Keep in mind we're using a grab pass here for our shield shader. If you aren't familiar with this whole project, we have a grab pass that is actually rendering everything inside of the shield and behind it. And so what this actually allows us to do is that's just a texture. We can just move a little bit over or crunch a bunch of stuff in the middle and do whatever we want. And so that is going to hopefully give us a way to manipulate this and actually get all of this stuff to work. So there's a bunch of ways we can do it. I think, I'm not sure if this is the best way, but currently the way we're calculating everything is just a distance between points. So we have a point of our fragment and a point of all the impacts, and we just calculate the distance between each of those and create a sum. We're going to do the same thing in this, but we're going to calculate an angle for each of them, multiply it by the distance, and then get an angle out of that. So hopefully that works. I don't think it's going to be too difficult, but we may run into some space issues. We may be in the wrong unit space. So this is the shader. This is where all the fun stuff happens. What we need to do is actually shift this. So we're going to just have a thing. I want to actually pull this out. So float amount. And so this is our calculation. It's kind of gross, but that's the calculation for how strong our impact is at that point. And then if I multiply or add that back to the emissive plus equals amount, we should get the same thing. I'm going to take that float away. My syntax highlighting is going to be a little bit different, and some things may look slightly different than what you're used to. I installed ReSharper, so that's where that's coming from. So we should get the same thing. That flew through, but that's mostly just because of compiling issues. So this is exactly the same. We didn't change anything. The only thing we changed is now there's an amount here, and I can use that in my calculation. So we're going to have float 3, and this is going to be our position change. I don't know if that's a good name for it, but we're going to just say this is equal to 0 initially. So there's no change at all. And then we're just going to sum all of this. So our position change plus the amount, so how strong it is. In this case, the blue, if it's very blue, that is actually going to represent a stronger force here. And so we're actually going to use that to make this ripple stronger. It doesn't really fall off as much, but we'll get to that. So we've got our amount, and we're going to multiply that by the difference. And so to do that, we already have a calculation for that. These two. So we just need to take our object position and our points position. So the point is going to be where our thing impacted. And then the object position, where our fragment is actually the direction. So I actually want this to point towards that point. So if I subtract the object position, I think I'm doing this right. I always forget which one goes first in a difference, but I'm like 85% sure that's the way it should go. And so now we have a vector and an amount. What I can do, because this is going to actually be, it's not a normalized vector at this point, it's a distance vector. For this purpose, I'm going to actually normalize this. And the reason we're going to normalize this is this way our direction is based on the amount and not based on the distance from the impact. We can add that later, but I feel like it'd be better to do that as a separate calculation than to do it together. So that's sort of what we're doing here. Now we have the position change. I'm going to change that a little bit. Instead of doing this emissive and writing the point color, we're just going to write the position change, and I'll keep the point color handy. Point color, just in case. But for now, we're just going to write the position change. So we should see a normal written now as our emission instead of just a color. So that blue should go away. And we should see this. So this is the normal. And it looks like we're not getting what I would like. So if I pause this quick, you can see we have some green, we have some blue, and we have some magenta. It's three-dimensional. And so part of the problem we're going to run into is we can only shift our grab pass in 2 dimensions. And so I think, like theoretically, we have this grab UV plus our refraction. The problem we're going to run into is it's not gonna work. If I shift it by what we're getting out, these are world positions. These points are world points where we hit. Actually, are they? Hold on. I don't think that's right. I think I'm getting this totally wrong. Yeah, these are in object space. That's still not going to work because I need them in the view space. So our grab pass is in view space. It don't, or is that the word for it? It doesn't matter. It's we took a picture, right? And so we can only use the data in that picture. I can't like wrap around it or anything like that. There's none of that other information exists. And so when I have all these coordinates in other unit spaces, in other spaces, it just doesn't work, because if I'm trying to work in object space, that's relative to the object. All of these coordinates are relative to the object that we're impacting, not relative to the camera. And so we're going to need to translate this position change into something that we can use in the camera, and then use the X and Y as our U and V. Problem is, I don't remember the thing to do that. World to something, or object to screen? Pretty sure that's not a thing. Oh, I'm going to try it, and then if it doesn't work, oh well. So we're going to need a float 4 for this, because it's a 4D matrix, or 4x4 matrix. So I'll type vector or float 4 and ignore the fact that I typed a float 3 before, because I totally didn't do that. And then we're going to take the, I just care about 2 of them. I care about the X and the Y. Those are the only 2 positions I care about. The Z, we're just going to throw out. We can't do anything with that. Even if we wanted to, at this point, we can't do anything with that. So screen refraction is going to equal this. And we're just going to use the swizzle operator and pull out the X and Y. And now that we have that, we want to do a change to this. So we're going to do plus our screen refraction. And there's going to be some constant here that I'm going to have to multiply. I'm going to leave it just because we're going to get some interesting results. I hope we get interesting results. Yeah. And let's see what happens. I broke it. Pretty sure. Let me move my mic because I can't see the bottom of my screen. Let's see here. What'd I do? Wrote a bunch of things to the log. Object to screen doesn't exist. And we're doing a texture projection on something that we can't actually do a texture projection on. Those are supposed to be 4D, aren't they? We'll just make that up. Right? So our refraction input is, yeah, float 4. So we are going to need to use that there. So this has to stay a float 4. We take out the XY. Already did that. Now we need to figure out how to do this object to screen space. I'll be right back because I need to look up what this constant is. There's some matrix somewhere, I'm pretty sure, that will get us this, because what we have right now isn't going to work. Actually, why not? We can do a float for position change 1. And this is just going to create a 4D matrix or 4D vector from our position change. So we'll still get refraction. It's not going to look right, but we'll get refractions. Theoretically. Yeah, and we are. I don't know if you can see those because they're pretty slight, but they definitely are there. Yeah, so you can see this tiny little band kind of running across. See how the wing doesn't align anymore on both sides? You've got this part where it's kind of lifted off and this part that is not. It's working and doing the thing that we want, just a little bit differently than we want. It's not refracting around the sphere. It does look kind of cool though. We get this cool little distortion at the hit. We actually might just be able to use that. Hold on, let me just remove this emission and see what this looks like. Because that may just be something that I want to keep. So you can kind of see it's sending the shockwaves across. It doesn't fall off at all because we're literally just shifting it at a hard edge. That's what if we rounded out that hard edge at the edge, we wouldn't get these hard things. But we are. I need to tone down the lasers. There are too many things flying at the screen. Can't tell what's going on. So we'll wait for one to hit there. That was less useful. Okay, I need to stop hitting pause. Not gonna help. Yeah, so it's just not refracting in the right way. It's pulling things in the opposite. Oh, is it? Kind of seems like it just pulls it. All right, you know what? I'm gonna actually say I like that effect. It's a little bit different than what I was hoping for or thinking of, but it actually works out pretty well. So we're going to bring this point color back. And we are going to also modify, I need a refraction color. One thing, this red underline, that's not an error. That's not an error code. You can see it's white here. One of the cool things that ReSharper added is you get a little color preview when you do colors. So like you can see this is fuchsia or purple or whatever you want to call it, which is just red and blue. And so that's kind of neat. It does do opacity as well. So like darker red. But anyway, I thought that was cool. What do I want? I want a impact ring refraction. Refraction. There's an R in there. All right. I've spelt that wrong in pretty much every way. I'm going to call that the refraction amount. Going to change that real quick, but for now it can just stay there. Impact ring refraction. There we go. And then as always, we need to copy this down here. So float. There's that. And then really the only thing we need to change is we included with this amount, we need to multiply it by a impact ring refraction. And that's it. Nothing else to it. So this should now refract by greater amounts based on how many things hit. Actually, I'm going to pull this out of here. We don't need to do that every iteration for every point. We can actually just do that in here, I think. This will give us the same result. So I can actually pull that out. We'll just do that here. So screen refraction times equals this. And so this way we're not repeating that same multiplication because we don't need to. Just doesn't seem like it's something we need to do. And that way I can modify the amount without having to modify that entire formula. So let's see what happens when I shoot it with a bunch of lasers now. We should see it still, there should still be blue, but you can see it when you hit, it kind of collapses the shield and kind of pulls everything into it. And it looks really cool. Okay, so that's sort of working. You can obviously change the refraction, and with this, because of the space we're in, I suspect it might look a little bit different based on where you are. Yeah. Does it? It's really hard for me to tell. So part of what I was expecting, I'll kind of go through and walk through what I was expecting to happen with this screen refraction here. What I would expect is everything should have effectively the same values for both the red and green. So everything that hits it on this side should all kind of point in that direction. So regardless of what happened, when it hits it like this, the right should be right, and the left should be the same color. It should match up regardless of where it hits, because what it's actually impacting is how much of it is actually changing, not this. That's not what we're seeing here. So some of it is different. We're also going negative. Just thought of that. The black is not black. I just crashed Unity. But the black is actually just negative color space. It could be just zeros, but more than likely it's actually just we have a negative value here. So if our direction is negative in the just going in any way that isn't positive, that's going to become negative, and that's not what we want. So, well, actually, no, that's fine because it's a screen refraction. Ignore that. Rant over. So what I need to do is figure out how to get this into screen space, into our camera's view space. And so I will go look that up while Unity is restarting, and we'll pick it right back up. Should just be this multiplication, and then we should be done, because that will get it into the correct space, and then we're good. But yeah, I don't know how to do that, so BRB. Okay, so I think I know what we need to do. There is a, whoops, that's not right. It's called the projection matrix. I don't know why I couldn't think of that, but we need this Unity MVP, which stands for Model View Projection. Projection is going to be, how do I walk through this? So there's a whole series of translations that your model goes through in order to actually render it. To get it on the screen, you have your object in object space. So all of your vertices, like if you have a cube, each of those vertices is at like 0.5, and you have a 1 by 1 by 1 cube, right? The problem with that is you want to be able to move the cube around. And so the way that's done, in order to support, say, translating it and moving it around and rotating it and scaling it, all of that is done in a matrix. That's the object matrix. My terms may not be correct. But so you have a matrix there. That gets it into world space. That's in Unity, that's your transform. That's what that's doing. It's representing its space in the world. There's another space, which is the camera and its orientation. And that is going to be specifically where is the camera looking and where is it positioned. And by taking that object, multiplying it by the translation or the transformation and its view, you should be able to get it so that you can know if it's in front of the camera or whatever. That kind of gets you into camera space. But there's an additional step if you're doing like 3D stuff. You want a perspective. So you want to be able to see more the further away you get. And so there's a perspective that kind of scales things by Z depth. That's what this P stands for. So we need the MVP matrix because we're working in 3D space. We have a perspective. There is a field of view. If we didn't have that, we wouldn't necessarily need it. don't think it does anything else. I could be wrong there. So don't take that as, or just use the MVP matrix. So this should take it from the model to the view to the projection, and then get us that out. So this should be in our screen space. So I don't know why that didn't start. Ooh, that's a lot of bloom. It does. So you'll notice though, it does appear to be at least somewhat correct. I don't know if the bloom is throwing me off. That is a lot, and I don't know why. I also don't know where our ship went. That's odd. But anyway, it's going to be really hard to tell if anything is refracting when it's doing that. You can see this now moves around. So as I shift my camera, oh, I multiplied that by a lot. There's our ship. So as I move my camera, you can see the colors shift. That's because we're now getting it into screen space. So those are actually relative to our camera. And I'm thinking that may not have been what I wanted. Because now that it's in the screen space, I know if it's along the X or the Y or whatever. I want to do. Yes. Okay. So Unity's updated that just to use their object to clip pose. And so I think we want to normalize this again. Yeah. So we're going to set this equal to our normalized screen refraction times that. We still want the normalize up here. That prevents anything from having too much weight just because it's too far away. We don't really want that. If we get rid of this, there will be no strength at the center, and I don't want that. So this is going to normalize it after it's gone through the projection, which is effectively going to shrink it back down. So that should prevent it from getting way out of hand like it was. And now our impact ring refraction should be added on, and we get that screen refraction again. So hopefully those colors dim way down. And then I can start this again. And we're back to this, which is good. And hopefully I can go along the sides here, and you can see it's sort of pushing things out. Actually pulling things in, it looks like. Yeah, so currently the way this is working is it actually pulls things out. If we want to flip that, we should, haven't tried this, but I'm going to say it anyway, we should be able to just make this negative. And now it's in that spot. That's odd. Kind of shifts around in there. We may be refracting more than I want. That shouldn't be happening. But this pushes it away, theoretically. No. No. Okay. We can kind of play with these. I'll leave some of this to you guys, so you guys can screw around with this as much as you want. I'll put the source code out on the Unity visualizations project that I have, which has just a bunch of projects we've worked on the channel. So you guys can go and grab that and play around with it, work with this or something else. If you guys have suggestions, I guess, I'm kind of wrap this up because we're kind of getting distracted because it's cool. But if you guys have suggestions, leave those in a comment below, or just reach out to me on Discord, our Discord channel or something like that. I love new ideas. And if you guys have something you think would be fun to kind of build as a channel, that'd be cool. So I'll leave it here. If you guys have feedback for me, let me know about that too. It's always nice to hear what you guys are thinking. So yeah, till next time, see you, Internet.